Topic 12-4 is the difference of squares. I'm first going to write ax squared plus bx plus c. This is what we have been factoring. If you'll notice the formats of these problems as we do these, you'll notice something of the format, that this middle term is going to disappear. Also, difference means subtract. So never is this going to be a positive, it is always going to be a negative constant. So difference of squares, and we talk about squares, so we need to know some of our squares, like 1 squared, and 2 squared, and 3 squared, and 4 squared, and 5 squared, and 6 squared. The more you can recognize the squares, the better off you'll be. So I'm going to factor these perfect square binomials. I'm still going to use tic-tac-toe because I love it. And there's 1, and c is -1, and a times c is -1. But I have to come up with 0, which means that signs are different, which is 1 times -1, and 1, and 1, and 1, and -1. So that is a minus 1 and a plus 1. And here we're going to do, now I told you to recall your perfect squares. Notice this is 3 squared and this is 2 squared. And there is a minus between them and there's no middle term. So we're going to do 9 and -4 and -36, and that's a square of 6 and -6. And to get 9, it's 3 and 3, and 2 and -2. So it's 3a squared minus 2, and 3a squared plus 2. So what is the pattern? A perfect square, square, okay, here's 1 squared minus 1 squared, here's 3 squared minus 2 squared. We'll have sum of 0, and notice when we were doing this, we needed a 0 term because this had to be 0, remember? And then the formula, you must take square root of first term, okay, and then first monomial, minus, that's where the word difference comes from, minus the square root of the second term, or monomial. Then the square root of the first monomial plus the square root of the second monomial. And technically, they say that ab squared minus 4 would be the square root of ab squared minus the square root of 4 times the ab squared plus the square root of 4. I never knew that there was a formula for it. Here's what I did. there's a square, no middle term with a minus. It is a plus 1, a minus 1. Here's a square, 3, the 3 times 3. B plus 2, 3b minus 2. And you can put them in any order. So you need to recognize the difference of squares and when they will disappear. So let's look at these. Is 1 a perfect square? Yes. Is 9 a perfect square? Yes. X plus 3, x minus 3. There's your answer. Is 1 a perfect square? Yes. Is 121 a perfect square? Yes. 11. So it's D plus 11, D minus 11. Now, check your rainbows, your inner rainbows. 11D minus 11D, middle term disappears. D squared minus 121. Is that a perfect square? Yes. Is that a perfect square? Yes. Is there a difference? Yes. 3H plus 12, 3H minus 12. Is that a perfect square? Yes. Is that a perfect square? Yes. K squared, J squared. We're just tacking on a J at the end. 5K minus 8 and 5K plus 8. Sorry for the puppy. He kind of likes to do videoing also. Is this a perfect square? Yes. Is this a perfect... Oh, I forgot my J's. Oh, I almost forgot my J's. Oh, that would have been bad. Okay, I know it's just my J's because I was going the next one. So there's a square here too. So, perfect square, 4x minus 7y, 4x plus 7y. Perfect square, 2z minus 3, 2z a plus 3a. You can tell I'm not used to those little squares. Remember, this is called the difference of two squares. That's not a difference. That is prime. So, please understand that you cannot disappear a middle term when you have a positive between the two terms. So this is something is, can you realize what's going on? So this is 1/3 C minus 8D and 1/3 C, oops, get that C up there, plus 8D. And that is the difference of squares. If you notice at the very beginning, I did the tic-tac-toe and I factored it. You can do that if you don't recognize it. So everything that I do, you can always go back to tic-tac-toe if you don't see it. Please be on the lookout for these guys because this is the one who is going to catch you, and this will be prime.